maybe see, we are in Lederhosen and we won a project in Bavaria, so that's why we are Lederhosen. And here we wanted to go to the manufacturing line and running Kubernetes there. So it was not easy, but we liked the project. It was really a pleasure to do this project, really a challenge for us. And now we want to report what we learned, what we discovered, and it's quite a lot. So let's get this started. Where I am, I'm Toby. I was already here in the first Container Days. So maybe who was there in the first Container Days? 1, 2, 3, okay. So as you remember, it was in a tent and the speaker was the fifth employee of Docker, so this was really fun. And then I have a talk. It was really nervous. And now I'm back here. And I'm happy to guide you. And then
so hi, I'm Mario. I joined Kubermatic 2 years ago, and for me it's the second Container Day, so not as experienced as Toby. And we work both at the project for the customer that created this manufacturing setup. And as you might have recognized, I'm the guy with the dog that runs around here. But let's get back to topic. So when we started, we have to take a look back in history. What is this industry and what was it in the past? And you can remember there was Industry 4.0 is what you see everywhere popping up and everyone is talking about it. So it means there have been 3 versions of industry in the past before. The first version that we had was when we finally got in some factories, we used steam power, and we've been roughly at the end of the 18th century, and slowly we stepped everything up and started everything in mass production. We had the first assembly lines, we used electricity, and then computers were invented, and computers started getting also put into factories, and we started computers at the 1970s. And after this, we went to Industry 4.0, the new big thing, and I think we are in Industry 4.0 since 20 years, because seemingly there's no 5.0, and we are talking now about cyber physical systems. We have physical virtual plants and everything, more digitalized. And to be honest, this is not the case everywhere. We are still far away from what Industry 4.0 can do, and all of the manufacturing sites now need some kind of compute power to run all of these analysis. So we want to have live analysis from what we are currently producing. We want to have motion control for all our robots. So everything that is produced in a factory should be updated and run on time, in time, because there are a lot of storage that needs to be provided at each location. We also need to have this in-time production, and we need to take care of so much things like cyber attacks from the outside. So we can't really open up our manufacturing site to the outside world. So we need to secure it, but also we need to connect to the other manufacturing sites that are placed all around the world. So we need to have an intercommunication between all of these different manufacturing sites. And this leads us to how do we solve like this huge amount of compute power, and how do we create a platform where all of this can run on. So we basically decided, let's go with what we always do with Kubernetes.
So basically for our customer, it was the choice Kubernetes is their really go-to technology. Why? They want to have a unique interface to manage all their resources. And if you remember, the core principle of Kubernetes was to abstract infrastructure, to abstract different cloud providers and use it. And that's what you can use also for this use cases in the manufacturing line. And for this, we said, okay, we just don't want to run Kubernetes there. We want to have a self-service platform where we can deploy at any time the compute power where we need. We can deploy on the application on top, and we have a unique layer across cloud providers, like in this case it was Azure and vSphere, on different data centers in different locations. So this was the goal, and like the customer said to us, hey, their project name is Digital Backbone, and that's you need to think about. This is a new digital backbone, the communication platform for the future, where we're now migrating things to it and being more flexible in the future. Okay, so then the project started and we said, oh, okay, that's quite a challenge. Then we came out, let's do some workshop. And then we identified a few key project targets. So one of them was like hosting, we're hosting not normally applications, we don't hosting web servers, we're hosting manufacturing software. What is the difference? Manufacturing software is often really old software, it's long maintained, it's maybe not as cloud native as a web server, and we need to migrate it, and we need to think about, okay, the manufacturing software does not communicate with maybe end users, it communicates with machines, and this is different. And where it runs in a separate network. So the manufacturing network is like the holy grail of this company. So it's really like super protected. It needs to be stable. It needs to be up and running every time. And we need to deploy inside of that. That you can see there was a lot of security requirements and restrictions. We need to come over it and convince also internal departments there, hey, that's the safe way how we can do it and how we want to do it. And as we told you that it's multiple data center, we're talking about 30 data centers across the globe. So we are growing there, having the cloud provider Azure, we have vSphere on different locations. So a lot of complexity. And for that we said, okay, we need to have high grade of automation. One other key point was that we want to be independent of each other. So our Kubernetes operation must be independent of the application operation and maybe the infrastructure operation of a lower level infrastructure, so that we can release a new Kubernetes version or a new platform version at any time. High availability, I will show it in detail what are meant by that, but it's also for sure for this use case important to be HA. In the end, we also learned, okay, it's not all about technique. It's also about communication and organization, as we have a lot of different departments where we need to come together and have like an end-to-end operation for all things, starting from the storage layer until the service layer. Okay, so why independence is so important? I mean, you learn it, if complexity is big, you should cut it down in smaller pieces and make it more simpler. If you follow this principle, it's also clear that you need to be independent from each other. So we don't want to affect the release cycle of an application team. Another way around, the application team don't want to be affected by release cycles of our platform. If we need a new bug fix release because of whatever reason, security, Ubuntu, bug fix, or something like that, we should not infect the real workload. And that was one of the key principles we followed there. So the next thing I want to explain was high availability. What does it mean? So we need a combined HA across multiple clouds and data centers. So we committed to that we manage it by the customer as a managed service with a SLA for 99.96. What means in minutes per month, 70 minutes downtime. If you maybe who operates Kubernetes cluster knows 70 minutes if something breaks is not much. So, we reached it now running more than a year, and we never broke it until now. So that was great, but also this was begin of our journey in the head. So, okay, we need to reach this high availability. Okay, then to the organization.
Yeah, so you need to work with your customer, and you can't treat the customer as a customer because you're in this together. And this whole installation is so big that you basically have a lot of people involved from the different departments. So we created together with our customer like a two-sided team. On our side, we have the team that created the whole platform and set it up and then handed it over to our managed service. And on the customer side, they also have a dedicated project team that collects all of the inputs from the different departments. Like you have the consumer department who creates the requirements for the applications that run on those clusters. You have the data warehousing team that says, yeah, you can go there or you can go there. And of course, what you have in all of big enterprise companies, you have a whole security department on which you have to align and which you also have to have an open communication to, because they want to secure the company, but they also need to provide access to the different parts. So we basically went for a split of competences, and the split of competences was pretty straightforward because we already knew there are different parts, and each of those parts will be taken over by a team, and you can have like interconnection between these teams, but they have like each of this team has its own competence. So we have on the first side, we have the co-infrastructure team, because somewhere your clusters have to run. So we have a team that manages the Azure cloud, the vSphere, and also you have the requirements for bare metal clusters that we want to utilize with KubeVirt in the future. They are also taking care of a little bit like the security team is in there as well, because they are taking care of the firewalls and all of the security interconnections for the networks. On the next side, we have the application platform team. The application platform team basically is our main connection point for the requirements, because they know where they want to run things and what they need and what their customers need. And they also have they provide the basic infrastructure for their consumers. So because you don't want to have 10 Kafkas, you want to have one Kafka that is utilized by all of those. And they also get the requirements to have we want the specific DNS routes, we want specific S3 buckets. So to the last team, which is a huge amount of teams, because these are the end customer users. They are not so much involved within the platform, but they are making the end requirements and also the additions that you need to install in those clusters or services that you additionally need to provide, because only having a Kubernetes cluster doesn't create a platform for you. And last but not least, it's us. So we are basically the team that provides all of the basic services. So the goal was that we also provide the local DNS, the S3, the monitoring, logging, and alerting. So we need to collect all of the data and manage it from a central position and give it back to the teams. So this is quite a huge requirement. So we said, yeah, we can do this.
Is that challenge accepted? Okay, we was young and motivated. No, but we did it, and it was for us also a challenge. And we like that to solve things where we don't know before. If you maybe think about, first we were scary about running Kubernetes in production. Now we are scary about running Kubernetes in a manufacturing plant. So and say producing chemical goods. So if there is something going wrong, it could be maybe have a big impact. So that was a little bit scary in the beginning, but as it was a great cooperation with the customer, we started to do it. And we said, okay, first thing what we need is complex. We want to have repeatable function units. So that's not code function units. It's more like building blocks where we say we can work independent from each other. And we can say, okay, these are manageable units. So we can also train other people. We need to manage it, operate it over a long time. So we need to also think about people will come into the project, will leave the project, how we can bring them the complexity to it. And so we modularized it. We said we want to manage everything via API and GitOps. So because that helps then, if you are new to a project, to handle the entry point, you see what technical is happening. So, but then we discovered, there's a firewall. And the firewall, I think everyone knows firewalls are awesome and we like them a lot. And the default communication was via email. And was, okay, fine, but we need a lot of firewall rules, different networks, different locations, interconnectivities. And then we said, okay, let's have a workshop together with the firewall folks. And then we came up really to a great idea. We said, okay, we building up object groups. We said, okay, we have a component that was running the workload. So that's the object group workload, and we have a component that's running the management workload. And then we have additional tags like location. Okay, we have the management network in location A, we have the management network in location B. But management A should not talk to workload B, and so on. You get it? It's getting complex, so we grouped this, and then we placed the rules based on of this. It was work, but then after it, we have a rule set, we can apply it, we can adapt it quickly. So if something get added, like a new data center, we can just add the data center to the management group. And that was really great. And you may be saying, oh, that's a fancy program. It's on GitHub. No, it's an Excel sheet. And it's this Excel sheet, but it's not bad. But this Excel sheet can be in time, if we want to, we can automate it. We can maybe write some CRDs, an operator, and automate it when we have time for it. Yes, and then if you go further, we said, okay, for these modules, we need to follow the infrastructure as code. As I said, if you come into a project, if you know, okay, that's the pipeline to deploy it, you come into the details, you come into the values, you know what are the configuration parameters, what I can change. And we said also, okay, we want to document directly by the code, and I can really recommend that, because this leads to it, you don't need to switch context. You have a PR, you can see, okay, that's the code change, you can document it, and you can say, hey, that's a review, a requirement to have the documentation inside of the code. And if you are in a service case, maybe in the night, you're tired, you don't know what's happening, and so you just make git pull, you have everything, what is current state in it, you have one repository, we can find every information what we need to fix maybe an issue. Good. And now the last point, a very important point, is standardization and scaling architecture. So we said we don't want to introduce like ununique APIs. We want to keep the standard APIs from Kubernetes, and we want to be scalable. So, and how we can achieve this with an architecture point, Mario will tell you.
Yeah, so we started in the past, hey, let's put code in containers so that we can run it everywhere. Then we started, hey, we need a platform where we can run multiple containers, so let's put it in there. And then we say, hey, let's put manufacturing sites into standardized containers and repeat them everywhere. So the idea was we create something that is not reliant on where I run it, and you can just reuse everything, and the base is repeatable in a short time. So we came up with basically what we use in our open source software, KKP, so Kubernetes platform. So we say, let's do it this way with the whole data center. So we basically created the idea that we have one management layer running somewhere. So we put it in our case in Azure because it is centralized for all of the locations. And then we said, okay, we put a seed inside of each of the locations where you have a data center. So you have like the control planes of your user clusters running directly next to your seed. So there's no interconnection, so you don't have to go to the internet or anywhere else. The good thing is, you can separate the line between the management layer and the data center layer because everything is running just inside of the data center. And then we came to the problem and thought like, okay, but what do we do with the rest that you need? Because there are a lot of things that you might not think of. It's like, who's taking care of DNS? Who's taking care of DHCP? What happens if I don't have an internet connection with my registry? Where can I create a new cluster when I don't have the images? So what we did is basically we built this data center service cluster that is also in each of the locations. And our goal was that we start with a failover by default. So we always go from the case, or by default, it's potentially everything is offline. Of course, there are some things that you can't replicate everywhere. For example, everything that is in S3 storage because it's just too much. But from the idea, we basically said, okay, we always have a local installation, and this local installation is also reachable by the other locations with a specific name. So we came up with this basic setup where we said, this is our default usage. Everything is called, it calls the local address. It's calling local.dns.manufacturing. If everything is fine, it doesn't have to go outside of your data center. You don't have any traffic outside, and we can populate it from top to bottom. And in a failover case, so if the local DNS is failing for whatever reason, we can go with, hey, I have like 10 other data centers that have the same information at hand, and I can just switch over to them. And this goes for all of the other services. So we have the registry that we can use. And in the very, very worst case, or if it's faster, we just use the master. So we can basically jump back to our master installation and use everything that is there. So we are completely, in each data center that we add, is another failover location that we add. So we increase security by adding more data centers if needed. And this sounds great in the theory, but it wasn't that easy how it sounds. So there was like a lot of failures, and the story of how we solved it and what steps we took will tell you Toby.
Yeah, so as you can imagine, a lot of things to think about, and we came to the point where we say, okay, we have those fields, and we need to cover them all, basically. Do we cover them all directly? This is difficult. So we decided we want to build up first an MVP, so minimal viable product, and then we can really recommend to do this approach, starting small, doing one time end-to-end, that you can already work with the platform and then improving by time. So that must be supported, but this was great. So we managed in, I think, 1.5 months to have a productive system running, and then the application teams could already work with it, collect experience, get feedback, and we can add it to the things. So what this in details was like local infrastructure. Okay, data center, great. Okay, first question, how I came to the data center? There was Corona crisis, so we could not drive there. So we needed a connection. So we have operating center. This have then a site-to-site connection to the networking. That's the entry routing network. Then we have from the routing network to the management network, then from the management network to the workload network, and everywhere that between it, we have firewalls and rules to apply. This takes a while until you hit every firewall correctly, and then we managed this. Then we came to the question, okay, we're creating every 20 minutes automatic backups from our clusters, great. Okay, but if, say, we store it on the data center, if the data center is dead, what's then? So we need to think about, okay, where we can replicate backups to be also disaster able. So that we say, if worst case, data center burned down, that we can recover and can build it up. And the same thing is for the core infrastructure. You maybe think, what's there special? But if you are on the on-premise world, you need to think about what compute storage network you want to build up, how you can separate it, how much you want to consume, and you also need to buy the hardware. So that's not so easy sometimes. So these topics were closely made with our customer, and then we came to the security. Security, firewall that we discussed, and network segmentation for sure, also fine. And then authentication. Okay, authentication, normally our service engineers can log in with their ID to the custom environment. In this case, it was not by policy not possible, so we need to think how we can create a lot of accounts, because the managed service team are rotating teams. It could people move in, move out, and we need to have a process around this. So and this was this point. Then next thing was services. Like you saw it from Mario's slide, that we want to have a S3 service. And this S3 service we should consume as a service on-premise in the same way as we do it in Azure. And we developed like small data center units where replicates and follow every time this data center data center approach. And here, for example, in Azure, the storage is different as the local storage, so you have different impact, and we wanted to hide it. So, and this was exploring. So I can only tell you, if you need to implement something like that, give your time to learn it and to analyze what is running and how it's running and how you can optimize. For that, we introduced the pipelines. I think everyone is clear why. Here we don't say, okay, we want to have it one tool and we want to pack everything in it. We just started with a makefile and executed the makefile from the GitOps pipeline. But it worked. And we have an entry point, we know what make target, and we have the tool behind it, and we see what's happening. And then we improve by time. So for example, for the service clusters, we added Argo CD, managing now the things over Argo CD. Independence. As our core platform, KKP, already has this concept, we adapted also to the services. We have a central master who is smart, who is managing everything, and we have local replicas. Why this is a good idea is the local replicas can be quickly recreated. They are more or less caches. They're not much to manage, and we have a central control unit. But in a disaster case, the local replica can do the same thing as the master. And after we are up and running, the important part is that you have an automatic reconciling. As standard Kubernetes pattern, you have a definition, you have a controller who looks, okay, target state, desired state, and tries to fit it. The same thing we do for the platform. Cluster management is basically our core business. We have a global API across clouds, and we reduce the complexity between Azure and a vSphere cluster to 3 lines. So basically the cloud provider, the data center of the cloud provider, and a pre-configured preset where we configure the secrets. So the consumer could create a cluster on Azure and vSphere by only 3 lines of changing. And for them, the feedback is that they don't really feel the difference where they run it. Because for them, it's a Kubernetes cluster, they have all services and can deploy the application on top of it. Cool. Last things about cluster management, what is also important, ops tooling. So dashboards for our operations dashboard, but also for the operation for the application. We give the customers the opportunity, we giving you a managed MLA stack, monitoring, logging, alerting. That some basics are in, and then you can add your applications dashboards, you can add your application alerting. And one nice thing I really like is if a user cluster alerts, then you're getting it until our vSOC. So we're getting it back from really the core application, an alert back to operations center, and someone can act on it. Cool. Then last points, applications. So they needed to migrate to cloud native design, and we need to be in the standard interface of this. Services, I explained, but services needs to also to scale. So we have autoscaling, and therefore you maybe think, oh, autoscaling is easy. Yeah, it scales easy up, but you want to be optimized. For example, we scaled up by default on Azure. We think Azure, everything must be fine, great. Then we looked at the utilization. In vSphere, we had around 50–70% CPU utilization was great. In Azure, we only have 25. What happens? We have a workload what had a lot of volume mounts. And in Azure, there are node types that only can mount 8 volumes. And then the autoscaler said, oh, I need a new node. So we have a lot of nodes what basically was not used. And then we changed the type using a more expensive type. Then the nodes get scaled down, but in the end, we was cheaper. And this was learnings what you cannot predict before. You need to analyze the workload and see, okay, what are the special behaviors, and then adapt to it. Okay, yeah, and then you start from scratch. No, not from scratch, but you're starting over and over again to try to improve and to match the targets. Also, requirements change over time, so that's really a good approach to follow the Agile principle. Then, summary.
Yeah, basically, the idea is that a platform needs to adapt by design, and every use case is different. You need to standardize, but you also need a modularity because you have so many different environments, and each of the use cases is different. So you need to come up with some modularity. Sorry. So and you need to be flexible to handle all of this, but you also need to have predefined components. And the result of this was as we can remember, there was like this 99.96% uptime. So currently we are on 100% uptime. We started the project with 2 people, and we are currently doing the project with 3.5 people. So this is quite a job that we did there. And the good thing was, with these 2 people, after 1.5 months, we already had it up and running. So there's always a next step. As Sebastian already mentioned in the keynote, so we eventually want to upgrade to KKP 2.21 because of the super cool new features, and we also want to utilize KubeWord there. So this is the next step with what we want to do. And also we want to expand to the edge, so to the assembly line, so to have like more edge devices connected to everything, and to also utilize everything what is in there. So basically that's what we wanted to achieve, and that's it from our side.
You were in time. You had 20 seconds left on my clock. It's pretty funny, like seeing Mario kind of hid behind that tree, but getting nervous and nervous and nervous when Tobias is finally finishing his points.
It's always the problem that Tobias is, when he talks, he talks.
He's talking too much. I don't have any questions here right now. Is that correct? Are you sure? There's one coming in. Big compliments. Nice.
Thanks.
This was the most realistic real-world Kubernetes access story I've heard so far. Okay, there's actually no question. I thought it might be coming. Factorio vibes?
Yeah. The idea is basically we are thinking of there's a request where a company runs robot dogs in their factory, and they are looking to explore this with edge devices and to have the compute power in there. So basically, what we want to have is like connect those dogs to the Kubernetes clusters that are running there. So yeah, we're getting to Factorio.
Okay, I think I try to pull you a bit more to the center of the stage, because for everyone who's online, you're hid behind that stand like the whole day.
Sorry.
It's fine, I think. But we need to see your lederhosen if you wear it.
Yeah.
I think it's just for that. Could a DNS failure in multiple remote locations lead to an overload of the master DNS? Do you keep any extra capacity for that failure case?
So basically, we auto-scale the DNS. Because we use ContainerDays, so we can just scale it up if it gets more load. This makes it pretty easy, and we always have like this top-down delegation. The only difference is the local registry, the local DNSs have all of the entries for the local ones in it, so they can also operate autonomously, and all of those are in replica sets that can scale up by demand. So we have not yet run into any issues there, but to be honest, we also have not tested it that way.
And I think the application requests are mostly locally in the network, so it's not changing too much.
To answer this question, is a 100% uptime for all the services? So yes, because when we update our cluster, the workload of the services by the customer is not affected, because this is running on the worker nodes of the user clusters. So if we update the control plane, for example, we always have an HA control plane, so we do one-by-one upgrades, but also it doesn't recognize the user clusters are not affected by this. Of course, what the application in the end that the user deploys on it does is up to the customer. But there you can also create a 100% uptime if you really want it, because you also can do the same approach, like have everything deployed in multiple locations and then utilize the different locations and then have just the failover, because you just have to change the DNS entries.
I think we can extend 1 or 2 minutes to answer the last questions.
Why so many locations? Why so many locations? Because you have so many factories all over the world. So you have like 10 factories all over the world, and it's just having a factory in one city and then in another city is just convenient.
And there was one requirement that each location must be operatable each alone. So they want to shut it up, and then everything must run.
Yeah. And also, yes, there are multiple manufacturing lines. So each data center has its own manufacturing lines next to it.
Okay. We have 2 more questions. You mainly talked about infrastructure. Did the org that you've talked about also settled on standard templates for their cloud-native application design? Did they?
Yes, so basically they wrote an application operator for their design. So basically the operator is like a template where the developer team only consumes then the predefined interfaces of their platform. And behind of this, they are free again, but they're developing like a few core templates what they can use for fast development.
How often do they add clusters? So they are not adding often clusters, but they could. So we have this air hockey table at our booth, and basically that's the idea. So you can create clusters on the fly and just throw them away and create them. It's just how much you need it. So the platform is not reliant on what. So we can do both. So either long-standing clusters or quick clusters. And why with so many small local user clusters instead of one big? Cost efficiency, because different departments have different cost centers, and you have the separation between teams, because a lot of teams just have their own cluster and it's only for them. And you don't want to share a cluster, and it's easier to have more clusters if it's your own cluster, so it's more secure, so you don't have to share.
I think you need also to think about technical when you think about different CRD versions or something like that, upgrades and so on. If you have smaller cluster, what you can create and throw away, you can test these upgrades more easy. And the effect, if you have 10 small clusters, if there's something breaking in one cluster, okay, then one cluster is dead. If you have one big cluster, your whole cluster is dead. So it's also a level of like lowering the impact if something breaks.
Breathe. Okay, that was your answers.
Yes.
Thank you so much. Is there a last question? Is it a quick answer?
I don't get it.
I don't get it either.
Okay,
But
so
you can ask
we just leave it with a maximum of 4 words, that question. Thank you so much.